Hey guys, welcome back. Today we will go over how to build a GameLift server SDK plugin for our Unreal Engine project, as well as packaging our project as a dedicated server. Now, if you remember from the graphic in part 1, the GameLift server SDK is essentially how the GameLift service will communicate with the game server and how the game server will communicate with the GameLift service. For example, the GameLift service will be responsible for creating matches and placing players into the matches. But then the game server will tell the GameLift service when a player leaves, when a game ends, and when we need new players. The way information is transferred between your game and GameLift will be through this GameLift server SDK. Before we download the GameLift server SDK, let's first get a build tool known as Cmake. Link to this download page will be in the description below. Once you're here, click on the Cmake MSI file for the Windows 64 platform, since I personally prefer the installer. When the installer is finished downloading, go ahead and start it up. Then select Next, and select the I accept the terms in the license agreement checkbox, and then select Next again. Now, you have to choose one of these Add Cmake to the System Path options. Whether or not you want to add the path of the Cmake folder to the path environment variable for all users or just your current user is up to you. I'm just going to do it for the current user, but either one of these options works as long as Cmake is added to the path environment variable so that we can run Cmake in the command prompt. Then select Next again, and click on Install. Do you want to allow this app to make changes to your device? Select Yes, and let the installation finish. Once the installation is finished, click on Finish. Let's just make sure everything went okay by going to the command prompt. So go to the search bar down here and look up command prompt. Click on the best match. Type in cmake --help and press enter. If cmake is a recognized command, then everything should be good here. There's also another build tool that we need to use in the command prompt, but we didn't add the path of the folder of that tool to our path environment variable. We actually already installed that tool in the last part of the tutorial, and that tool is MSBuild. So let's go back to the search bar and look up edit the system environment variables and click on that, and then select environment variables, and then under your user variables, select the path variable and click on edit. And then click on this new button to create a new entry, and then start typing out the path of the folder where your MSBuild executable is located. Now for me, using Visual Studio 2019 Community Edition, it will be c:/program files in parentheses x86 / Microsoft Visual Studio /2019 / community /MSBuild /current /bit. Then just press OK once you're done typing that out. Since we're here, let's actually add a new environment variable for our user. This will be used for preventing build errors when we build the GameLift server SDK. So click on this new button here. For the name, type in VS150 COMN tools in all caps, and then for the value, it's going to be the path of your Visual Studio Common Tools directory. Again, for Visual Studio Community Edition 2019, it will be c:/program files in parentheses x86 / Microsoft Visual Studio /2019 / community /common 7 / tools. Now, just a fair warning, both the name and value of this variable will be different for different versions of Visual Studio, so I will have all the possible names and values for this environment variable in the description below. Click on OK, then OK, then OK to apply those changes. To test all that out, let's restart command prompt by closing it and reopening it, and type in msbuild -help and press enter. If the command is recognized, then the path you added to your path environment variable is correct. If you get a message along the lines, however, of msbuild is not a recognized command, then that means the path of the folder where your msbuild executable is located is different than mine. I will post in the description below all the possible file locations where the MSBuild executable can be located by default. Things that can affect the path of the folder include what year of Visual Studio you are using, whether you're using Community or Enterprise Edition, or whether you got the Visual Studio build tools separately from the IDE. If that's all sorted out, we are now all set to download and build the GameLift Server SDK for Unreal Engine. Go to the Getting Started page for GameLift, link will be in the description below, and scroll down to where it says Amazon GameLift Server SDK and click on this Download Now button. Note that at the time we are making this video, the latest version of the SDK is 4.0.0, which supports Unreal Engine's version 4.22 to 4.24, which is why in this tutorial we are using Unreal Engine source version 4.24, and we highly recommend you do the same if you can, because if Unreal version 4.25 is out by the time you are watching this video, we're not sure what build errors you may encounter when building your Unreal Engine server. If you guys don't have a file extractor / archiver program, then I highly recommend downloading 7-zip. Link will be in the description below. I'd imagine you guys probably have some kind of software like this already, but I personally prefer 7-zip. Just use whatever you guys are comfortable with. Once the server SDK is finished downloading, go to where the SDK was downloaded in File Explorer. For me, it's the Downloads folder. Now this is where that file extractor program is going to come in handy. Right click on the zip file and select 7-zip. Then select Extract Files. And the reason I'm doing this is that I want to rename the folder so that I can shorten the directory path as much as possible, because yes, some people have had problems even extracting the SDK files because the directory path was just too long. So I'm just going to call this Server SDK and click on OK. We should further shorten the directory path of where we will be running commands by bringing the folders that we are interested in outside of this server SDK folder. So let's go into it, and as we navigate the SDK files, you'll see what I'm talking about when I say we have to watch out for long directory paths. Double click this GameLift folder, then double click this SDK release folder, and the two folders we're interested are the CPP server SDK folder and the Unreal plugin folder. So drag both of these to the downloads folder or whatever folder you want, as long as the folder has a short path. Let's go back to the downloads folder and into the GameLift C++ server SDK folder so that we can build a C++ server SDK libraries. Copy the path of this folder from File Explorer by pressing Ctrl+C and run command prompt in administrator mode by typing in command prompt in the search bar, right-clicking command prompt and selecting run as administrator, then select yes and type in cd, right-click to paste the path of the folder, press enter. And before we start running commands to build these DLL and lib files for the server SDK, we've noticed that this part of the tutorial generally gives a lot of people trouble. And although I was hesitant to put these DLL and lib files on GitHub, I saw a sample GameLift project released by Amazon that had the DLL and lib files in it. Since we're not really making money off of these tutorials and they are primarily for educational purposes, I decided to include the DLL and lib files for the server SDK on GitHub in the repository for this project, where all the code for the Unreal project will be for anyone who is struggling to build these library files. Link to that will be in the description below. But I still highly encourage anyone to continue watching and try to build these files on your own, because the commands we're about to use, Cmake and MSBuild, can take a wide variety of parameters, so there won't always be a one-size-fits-all pair of library files, because the library files can be customized by a multitude of parameters that can be passed to calls to Cmake and MSBuild for very specific niche purposes. But for this tutorial, we are going to build these files with the most basic parameters needed for our game server to function on Windows. We will handle Linux towards the end of the tutorial. Let's go ahead and make a new folder for our build files. Type mkdir out and press enter. Then let's cd into this newly created out folder. And then let's run Cmake by typing out cmake-g in quotes Visual Studio 16 2019 to specify the generator that we will be using, which is Visual Studio 2019. Then type -a x64 to specify the platform that we are building for, which in this case is Windows, and then -dbuild_for_Unreal in all caps and set that equal to 1, and then ... and press enter to run this command. If you're using a version of Visual Studio that is older than Visual Studio 2019, then the cmake command we just typed out and ran will look a little different. Take the cmake command I have typed out here for Visual Studio 2017, where the generator parameter now includes both the Visual Studio version as well as the build platform, instead of separating the platform into its own parameter. The rest of this command, however, is pretty much the same. Don't run this though if you're using Visual Studio 2019. This was just to show for people who aren't. The final step for building these libraries is running MSBuild. So let's type MSBuild all_build in all caps .vc xproj /p configuration =release and type enter. This command will build the all build Visual C++ project file with the release configuration. Now, if you didn't quite catch all the commands, that's fine. We will have them in the description below. Once that's done, you will probably see some warnings. Just ignore those, and to check that everything worked okay, go back to File Explorer, specifically the GameLift C++ Server SDK folder, and click on the out folder, then go to the prefix folder. Now, in the bin folder, you should see a file called AWS SDK GameLift server.dll. If we go back and check the lib folder, you should see a file called AWS SDK GameLift server.lib. Same name as that file we saw in the bin folder, but different file extension. If you saw both of those files, then you did the last couple of steps correctly. We have to add these library files to the GameLift server Unreal Engine plugin folder, so let's open up another instance of File Explorer, specifically where we put that GameLift Unreal plugin folder. For me, it was in the downloads folder. Open it up, then go to the UE 4.2 4.3 folder, since we are using Unreal Engine version 4.2 4.3. If you are using a version of Unreal Engine that is greater than 4.24, just click on this folder anyway, but just be aware that there may be issues not accounted for in this tutorial series, considering that at the time of filming this video, the latest stable version of Unreal Engine is 4.2 4.3. Then open up GameLift Server SDK, then third party, GameLift Server SDK again, and Win64. And this is where we are going to be putting those DLL and lib files we just saw. So let's copy the lib file we have here by pressing Ctrl C, then paste it here by pressing Ctrl V, and do that exact same thing with the DLL file, which was back in the prefix folder and then the bin folder. So again, take this, press Ctrl C to copy it, and paste it here by pressing Ctrl V. Now let's add the plugin to our project that we created in the last part of the tutorial. Luckily, I have it open in File Explorer, so let's open that up and create a new folder by right-clicking here and select New Folder, and we'll name this folder Plugins. Open it up and go back to the GameLift Server SDK, specifically the UE 4.2 4.3 folder. Copy this GameLift Server SDK folder and paste it in the Plugins folder. Adding the plugin to our project isn't enough, however. We still have to enable the plugin in our uProject file, add the server SDK as a dependency module in our project build file, and create a new target file for our server build. So let's go back to the project directory here and go to the source folder and select this editor.target.cs file, copy it and paste it here, and then right click it to rename it, and change the editor here in the editor target file, and change that editor to server so that the file now says GameLift tutorial server.target, and of course get rid of this dash copy here in the name as well. So go back to the main project directory again, and this time open the GameLift tutorial solution file. Once the project is open in Visual Studio, go to the right under where it says Solution Explorer and expand your project if it is not already expanded. Then click on your project's uProject file and add a comma at the end here, then in double quotes type in plugins, then a colon, square brackets, and then some squiggly brackets, and within those squiggly brackets type in name in double quotes, colon, in quotes again, GameLift Server SDK, and then add a comma at the end of that line, and then type in enabled, and then a colon, and then type in true without double quotes, and then press Ctrl S to save your changes. Then go back to the Solution Explorer on the right, expand the source folder, then expand your project folder, and double click the GameLift tutorial.build.cs file. And where it says public dependency module names.add range, at the end of this list of strings, just add a comma and then another string that says GameLift server SDK, and press Ctrl S again to save your changes. You may have noticed on the right in the Solution Explorer that your server.target.cs file is not here. That's okay. The reason for that is we haven't regenerated the project files yet. However, we still want to edit it, so go back to the File Explorer, specifically the project source folder, and double click your server.target.cs file to open it in Visual Studio. And basically everywhere where it says the word editor, just change that to say server. So here, and here. And then at the top of the class definition, just add square brackets, supported platforms, parentheses, Unreal platform, class.server. And press Ctrl S to save your changes once again. And before we regenerate the Visual Studio project files, let's go back to the source folder in File Explorer, and what I like to do is create a public and private folder in this project folder here. So right click and select new folder, name this one public, and do the same thing, create another folder, but this time name it private. Now generally the header files would go into the public folder while the C++ files would go into the private folder. So press Ctrl, hold it down while selecting the header files, and then just drag them into the public folders, and do the exact same thing with the C++ files, except this time drag it into the private folder. And there may have been a setting that does this automatically for you when you create a new project, but I must have forgotten that, or I've also heard that when you create a new C++ class that these folders are created automatically, but someone please correct me if I'm wrong. Now we can go back to the main project directory, right-click the U project file, and select Generate Visual Studio Project Files. I forgot to mention that it's generally better to close Visual Studio before generating the project files, but it shouldn't matter too much. Go back to Visual Studio and you may see this prompt that says File Modification Detected. The Solution GameLift tutorial has been modified outside the environment. Just click on Reload. After your project is reloaded, you'll notice right away that the server.target.cs file now shows, as well as the private and public folders that you created. Let's proceed to build this project. Make sure you have development editor mode selected for your configuration, as well as Win64 for the platform. Right click your project and select build. After the project is compiled, go back to File Explorer and double click our U project file to open our project in the Unreal Engine editor. To make sure that we have successfully added the plugin to our UE4 project, go to Edit up here, then Plugins, and scroll all the way down to where it says Project. Select that, and you should see the GameLift Server SDK and that it is enabled. If that is the case, then you have successfully added the GameLift Server SDK to your project. Let's begin to add some very basic GameLift server code. So go back to Visual Studio, go to the Solution Explorer, expand the public folder, and double click the GameLift tutorial gamemode.h file. Add an include statement here at the top for the GameLift server SDK header file. Hashtag include in quotes GameLift server SDK.h. I know it's not generally recommended to add a include statement in a header file, but when we add more complex code later in the tutorial, this include statement will make more sense. Let's now add some structs. So up here, I'm going to type U struct in all caps and then parentheses, and then underneath that struct, F start game session state, and then some squiggly brackets here, and inside these brackets, we're gonna write generated body in all caps with some parentheses, and then we're gonna define a U property of type bool, and we're gonna call this property status. And then we're going to make a constructor for the struct, so fstart game session state, parentheses, squiggly brackets, and we are going to set status equal to false by default. Generally, I try to use Unreal Engine macros as much as possible, such as uStruct, uClass, uProperty, uFunction, and etc., so that we can take advantage of Unreal Engine's reflection system. If you don't want to use them, that's fine, but before I move on, these structs that we are making are going to be passed to Amazon GameLift callback function. So, for example, this fStartGameSessionState struct will be passed to the onStartGameSession callback function, which gets called when GameLift wants to notify our server process that it wants to activate a new game session on the process. The scope of these callback functions, which we will code later, is outside the scope of the GameMode class, so the StartGameSessionState struct will be a bridge between our server process and the GameLift service. For example, if we want to know if the server process had successfully started a game session, then we can relay the status of that to the struct and therefore back to the GameMode class. Let's just keep coding, and once we start writing the GameMode C++ class, I'll explain each callback function more in depth one by one. Let's write another struct here. So again, uStruct in all caps, and then underneath that struct fUpdate game session state, and then squiggly brackets, once again, generated underscore body in all caps. And then under that, we're actually not going to define any properties here. We're just going to have a constructor that's pretty much going to be empty inside. Let me just fix that typo. So the reason why I'm not adding member variables for the update game session state struct is that since the onUpdate game session callback function is a little complicated and we are just adding basic server code right now, I'm going to deal with this more later in the tutorial, but not much right now. And once again, let's write another struct, uStruct once again, underneath that struct, and fProcess, terminate state, squiggly brackets, generated underscore body, and this time we will define some member variables. So the first one will be a uProperty of type bool, and it will be named status. Then we're going to have another member variable that's not going to be uProperty, but it's going to be of type long, and we're going to call it termination time. And then we're going to make a constructor for the struct as well, where in the constructor we will set status equal to false by default. Now, why didn't I make termination time a uProperty? It was because variables of type long cannot be uProperties. Why is it a long? Because we will be calling a function later on that returns a long. And let's write our last struct here. Once again, uStruct, underneath that struct, and this will be called fHealth check state. Some squiggly brackets, generated underscore body. This struct will also have a uProperty that is of type bool and named status. And in the constructor, kind of like some of the other structs, we're going to set status equal to false. And that is our last struct that we are making. Now let's make some member variables in our GameMode class for the new structs we just made. So scroll down here, and I'm going to make all these member variables private, so just type that out. And we're going to make all these variables uProperties. First one will be of type fStartGameSessionState, and we're going to call it StartGameSessionState. Now you're going to realize that I like long variable names because I like to be descriptive with any names I have, but you don't have to do this. If you like shorter variable names, then you can do that as long as you're comfortable with that and you can keep track of those variables. So let's just keep going here. uProperty again. This one will be of type fUpdateGameSessionState, and we're going to call this UpdateGameSessionState. Next one will be of type fProcessTerminateState, and we're going to call this ProcessTerminateState. And the next uProperty will be of type fHealthCheckState, and we're going to call this HealthCheckState. Also, I made a typo here. It should be terminate. Last but not least, we have to override the begin play function because all the AWS initialization code has to happen in that method. It can't happen in the constructor. So we're going to make this protected, so just type out protected here. And then we're going to write virtual void begin play parentheses and override. And press Ctrl S to save that. Alright, let's edit our GameLift tutorial game mode C++ class by going to the private folder in the Solution Explorer and double clicking the file. First thing we have to do is create the begin play function, which has a return type of void, and then type out a GameLift tutorial game mode :begin play parentheses and squiggly brackets. The first thing we're going to do in this begin play function is call super : begin play. And this is going to call the parent class's implementation of the begin play function, so the A game mode based class implementation of begin play. Because begin play does a lot of things under the hood that we still need to do in our begin play function. Then type #if with _GameLift in all caps and just close that if block off with #endIf. So the with GameLift macro is defined in the GameLift server SDK and is meant to essentially designate snippets of code to be run in server configurations only. When we built the project in development editor configuration, it would normally build all the code in the project, but now whatever we put in this if and if block will not be built nor run in the editor. The point of this is that sometimes you want some GameLift code, or really any code, to only be built or run in the server. Let's initialize the server SDK by typing auto init SDK outcome equal AWS GameLift server init SDK. So a couple things might look a little foreign here. In Unreal Engine, when you have a non-void return type function and you set the return result of that function to a variable, you can use the auto keyword to infer the return type instead of typing out the entire variable type. So for example, init SDK returns an object of type AWS GameLift server init SDK outcome, which is a very long word to type out. So throughout this tutorial series, we will use the auto keyword instead of typing out very long variable types. To check if init SDK was successful, then type if init SDK outcome is success. And if it was successful, then we can start creating our callback function. So the first one will be auto on start game session. We're going to set that equal to square bracket, and this function is going to take two parameters. The first one will be of type AWS GameLift server model game session, and we're going to call this parameter game session obj, and the second parameter will be of type void star, and we're going to call it params, and then just add some squiggly brackets below. The first parameter, which is of type game session, is going to be passed by the GameLift service, while the second parameter, which is of type void star, is going to be passed by us. It's going to be that struct that we just made a little while ago in that header file. And GameLift invokes the onStartGameSession function when GameLift wants to notify our server process that it wants to start a game session on the server process for a match or whatever purpose. So in this function, the first thing we're going to do is cast that params parameter. So type out fStartGameSessionState star, so that's the name of one of the structs that we made earlier, and we're going to call this struct state, and we're going to set it equal to, in parentheses, fStartGameSessionState star params to cast that params to a variable of type fStartGameSessionState pointer. And then after that, we're going to set the status member variable of that struct equal to AWS GameLift server activate game session is success. A couple things here. When the onStart game session callback is invoked, the server process has to call activate game session to notify the GameLift service that the server process has started a game session and is now ready to start receiving new player connections. This is essentially a way for the process to let GameLift know that it acknowledges the request to start a new game session and agrees to do so. We check if activate game session is successful and store that result in the start game session state status variable, because this struct is once again the bridge between our game mode class and this callback function. Although the scope of this callback function looks like it's in the game mode class, it's really not. So without this struct, there's no way for the game mode class and the server process to know whether or not the onStart game session method was ever invoked, and it'll never know if activate game session was ever called. And one last thing I forgot to mention about this game session object is that it may have information about the match, such as the players involved. Moving on to the next callback function, let's type auto on update game session. And we'll set that equal to square brackets and parentheses. In this function, it will take two parameters. First one will be of type AWS GameLift server model update game session, and it will be called update game session obj. And the second parameter will be of type void star, and we're going to call that params. And then just add some squiggly brackets. Now, we're not going to do much in this callback function, like I said earlier, because onUpdateGameSession gets invoked by GameLift when a match backfill request gets fulfilled. For example, if two players join the match at first and you initiate a match backfill request for two more players to join, and GameLift is actually able to successfully pair two more players to the existing match, then this updateGameSession object here will contain information about not only the two existing players, but also the two new incoming players. So all we're going to do in this function for now is just type out f update game session state star, call this variable state, and set that equal to f update game session state star params to cast this second parameter here to our struct update game session state. This is just a placeholder code for now. We will eventually come back to this function later and write more code when we do implement backfill. Let's move on to the next callback function. So type out auto on process terminate and set that equal to square brackets, and this time in parentheses there's only one parameter for this function, and it's going to be of type void star, and it will be called voids param. Type out some squiggly brackets. And what we're going to do in this function is what we did in the past callback function. So take the params parameter and cast that to one of our structs. So type out f process terminate state star, call that state, and set that equal to f process terminate state star params. And the onProcessTerminate function gets invoked by GameLift when one of three cases happen. 1. GameLift believes that your server process is unhealthy from the status report from the onHealth checkState callback function, which we will write after this function. 2. Your server process is on an EC2 instance that experiences what is called a spot interruption. So since we will be using spot fleets instead of on-demand fleets, this is very relevant to us. We are using spot fleets because they are cheaper than on-demand fleets, but like the name of each fleet says, spot fleets are quote-unquote spotty, so they contain resources that are subject to being taken away and used for a higher priority purpose, while on-demand fleets are deemed higher purpose and higher priority because someone is paying more money in order to demand more resources. Therefore, spot fleets are kind of like leftover resources, but that does not mean spot fleets are bad by any means. In many ways, besides price, they are actually better, and these spot interruptions rarely happen, but they still happen. And 3, your fleet instance capacity starts scaling down, whether it's automatically or manually. So for example, if you have 3 instances running in a fleet, but the instance capacity goes down from 3 to 1, then all the server processes on those 2 instances that have to shut down will have the onProcessTerminate function called. What you can also do in this function is you can get the time at which your process will terminate by typing auto get termination time outcome and set that equal to AWS GameLift server get termination time. And then you can check if the outcome was successful. And if it was successful, then let's store the termination time in our state by typing in state termination time equals get termination time outcome dot get result. And this function returns a variable of type long. So what is the significance of the termination time? I won't be using this variable directly in this tutorial, but depending on how much time you have until the process actually terminates, You can do things such as game cleanup, notifying players that the game is about to end, getting players into new games, and etc. But again, it depends on how much time you have, and the only way for the game mode class to know about this termination time is through our struct that we pass in through the params parameter. This is again important because you won't do things like cleanup and notifying players in this callback function. It will be outside this callback, so you need a way to relay the information back to the server. And something we need to do in this function is called the process ending function. To do that, type auto process ending outcome equal AWS GameLift server process ending. Now, process ending lets GameLift know that the server process is shutting down. So the process is acknowledging that the process is indeed terminating. And we should check if process ending outcome that is success. And if it is successful, then we'll set state-status equal to true. Because again, in case you want your game mode class, which is outside this callback function, to know that the process is terminating for one of the 3 reasons mentioned earlier, so that you can start doing things we just talked about like server cleanup. But for this project right now, since this will be very basic server code, we will just quit the program by calling f generic platform misc request exit, and we'll pass false to this function. The point of me writing this line of code is basically me just saying if the process gets interrupted and has to end for whatever reason, then sure, we acknowledge that and we will end the process by shutting down the application. Just a final note that you do have to call process ending to let GameLift know that you have chosen to end the process, but the graceful termination of the server is still your responsibility. In this case, I'm just ending the server right away when the service invokes onProcessTerminate to let us know that this process will end soon. This is not the only way to handle this though, there are many ways to do this correctly. The last callback function will be onHealthCheck. So let's type out auto onHealthCheck and set that equal to square bracket, and in parentheses this function will take in one parameter of type void star and it will be called params. And add some squiggly brackets. And inside this function we will do what we've done before. We're going to take the params and cast them to one of our structs. So type out f health check state star, call this state, and set that equal to f health check state star params. And let's just set the status of this state to be true. Just a bit of background on onHealthCheck. It gets invoked by GameLift every 60 seconds to check on your server process to make sure that it is healthy. If you return true from this function, then that tells GameLift that the process is healthy. If you return false from this function, then that tells GameLift that the process is unhealthy. If the function, for whatever reason, doesn't get called, crashes, times out, or fails to return anything, then that also tells GameLift that the process is unhealthy. In the cases where GameLift thinks the process is unhealthy, then onProcessTerminate, the callback function we just wrote earlier, will be invoked. In our case, we will always return true, so go ahead and type out return state-status. Alright, so now we have to handle how we're going to tell GameLift what port our server process will run on a specific EC2 instance. To do that, we'll do it through the command line argument. So let's make 2 arrays here. So tarray, this will be an array of f strings, and this first one will be called command line tokens, and the other array will be same thing of f string, and we'll call this one command line switches. And we'll also make a integer variable for the port so that we can set it to f_url config.default port, so that we can have some kind of default value for the port. To parse the command line arguments, we have to call f command line parse, and then in parentheses this will take f command line get, as well as the 2 arrays. let me fix this typo here. So before I move on, let's go over what command line tokens and switches are. So let's say we start our server process in the command line by running this command: GameLift tutorial server.exe token -port equals 77777. Command line tokens will be all the space delimited strings. So for example, GameLift tutorial server.exe token and -port equals 7777 would all be tokens. Now switches are a little more specific. There are all the space delimited strings that start with a hyphen or dash. For example, -port equals 7777 would be a switch, specifically a key value pair switch. You can also have a switch without the equal sign. So for example, if I got rid of this, -port would be a switch specifically known as a plain switch. But we will be mainly concerned with the key value pair switches. So let's iterate through these switches by typing out for, then in parentheses f string str colon command line switches, and then squiggly brackets. This is known as an enhanced for loop for iteration, and inside this loop, let's define two local variables, f string key and f string value, to signify a key value pair. And then let's split the string on the equal sign delimiter. So let's type out if str.split equal sign, and then we'll also pass in ampersand key as well as ampersand value, and then some squiggly brackets as well. Then let's check if the key is the port, because we only care about that specific argument. So let's type out if key.equals port, and add some squiggly brackets again. If the key is the port, then the value should be the actual 7777 value, for example, in this case, if we go back up here. And we should get this value and store it in the port variable that we define a little bit above. So we'll do port equals fc string atoi, and then in parentheses star value. The atoi command just converts a string into an integer, but all of that code we just wrote out should retrieve the port number from your command line arguments. Alright, now we have to work on a list of directory paths to game session files that you want Amazon GameLift to store for future access. So let's make a new variable of type const char star, and we'll call that log file, and we'll set that equal to a string that says a log file.text. Note that this log file doesn't have to be like an actual file, it can also be a directory path as well. So then the next variable we're going to define is going to be of type const char star star, and we're going to call this log files, and we're going to set that equal to ampersand log file, so the address of the log file variable. And then we're going to define another variable of type auto and call that one log params, and we'll set that equal to new AWS GameLift server log parameters, and this will take in two parameters, log files and then number 1. The 1 just signifies how many directory paths we have in that log files variable. And essentially what this does is every time a game session starts, GameLift generates files for logging. Now that file will be called a log file.txt in the root directory of your game folder. Again, it doesn't have to be a literal file path, it can also be the path of a directory. We are now ready to construct the parameters that we will pass to a call to process ready. So let's type out auto params, set that equal to new AWS GameLift server process parameters, and this object is going to take in a lot of parameters here. So the first one will be on start game session, the callback function, as well as ampersand start game session state, which are the parameters for that callback function. And then we have on update game session, another callback function, as well as its params. ampersand update game session state, and then the next callback function, which is on process terminate, as well as its params, ampersand process terminate state. Then we have on health check, the final callback function, as well as its params, health check state, as well as the port and star log params. And don't forget the semicolon here. So that'll be pretty much it for the parameters. Now we have to call the process ready function, which will notify the GameLift service that the server process is now ready to host game sessions. So let's call that function by typing out auto process ready outcome and set that equal to AWS GameLift server process ready in parentheses star params. The reason why I set the result of the process ready function to a variable is because I have seen that before in other code snippets. However, process ready usually succeeds, so I'm not really sure why other people do that, but I guess if you want to be extra careful and handle a process ready failure, then you can use that variable by calling isSuccess and get error on it. But for this tutorial, I won't do that. We are finished coding the GameMode C++ class, so let's build our project now, but this time for the solution configuration, select development server. For the platform, still Win64, right click the project file and select build. This way we can actually build all the new code we just wrote, and note that for many of you, since this will be the first time building in the development server configuration, this will take a while. Also, the code changes applied to the GameMode header and C++ files will be posted separately in the description below. The whole completed project will still be on GitHub. Once the project is finished compiling, let's go back to the project in Unreal Engine and let's change the packaging settings by going to File, Package Project, and then Packaging Settings. And then under where it says Packaging, just expand this section and then scroll down to where it says List of maps to include in a package build, and click this plus button here to add a map, and click the three dots to choose a map. Now normally when you open this for the first time, it'll take you to the content folder first. So once you're here, click on third person CPP, then maps, and then select the third person example map UMap file. And then scroll down to where it says project and select the checkbox by where it says include debug files. Because I personally like having the PDB file as part of the build, but just warning you, it does make the build a lot bigger, but we need that if we want to see more specific logs for debugging. Then go to the left under where it says project and click on maps and modes. Here we are going to configure some map and game mode settings for our server build. So first expand this default mode section, and for the global default server game mode, select none and click on GameLift tutorial game mode class to select the class that we were just working on. Then scroll down to the default map section and expand that section, and then for the server default map, click on entry and replace that with the third person example map. Alright, we should be all set to package our server build, so just close out of this window, go to File, Package Project, and for your build target, select GameLift Tutorial Server, then go back to File, go back to Package Project, but this time select Windows and select Windows 64-bit. For the directory where you want to put your build in, I generally place it in the main project directory, which is what you see now, and then I ignore the build folder from Git, but you can literally put the package build anywhere. I'm going to go ahead and click select folder, and I'm going to let that build. If you're interested, you can click on the show output log button here if you're curious to see the packaging logs. If the build was successful, then congratulations, you have built and packaged a Unreal Engine dedicated server application. Just double check, go to the directory where you put that build in File Explorer. Again, for me, it was my project directory, and in there you should see a folder called Windows Server. And that will be it for this part of the tutorial. Once again, feedback is highly encouraged, so please comment down questions below, talk with us on Discord. Special thanks to our patrons and donors, and don't forget to like, comment, subscribe, and follow us on our other social medias. See you guys in part 3.